For this next section, what you need to do is be able to understand the kind of concept of chart datum. Chart datum is like an imaginary line that everything else is measured from regards to navigation at sea. And chart datum is actually the lowest astronomical tide, and I think it's taken over 18 years. So it's the lowest possible, the least amount of water you'll find in a given area. So we're back in the Eastern Solents, and this area is just outside of Portsmouth, near the submarine barrier. And we're just going to look at some of the depths here. So we've got this number 3, for example. What that means that at the lowest possible tide, there is always going to be 3 meters of water there. And then moving across, this one here, at the lowest possible tide, we're going to have 2.4 meters of water there. And then just moving up towards this way, I don't know if you can quite see that, but what it is, it's a 0 with a line underneath it and then a little 9, and that means at the lowest possible tide there'll be 90 centimetres of land there. This figure here, that at the lowest possible tide there'll be 10 centimetres of land there. So what this means that for this 3, for example, we can add the actual tide to that. So assuming that we've got 2 meters of tide, we could add that to that figure, which would give us 5 meters. So at that given time, we'd have 5 meters of water at that point. Okay, what I've just jotted that. I've just done a quick sketch of what I've just talked about. So we mentioned we've got 3 meters of water at below chart datum. So what I've done there, I've drawn the imaginary line of chart datum on there, and then 3 meters to the seabed. This line is the seabed. This line is chart datum. And then I said, that's hypothetically, but we've got 2 meters of actual tide. So that's measured to chart datum, remember. So from the surface to chart datum, that's 2 meters. And then this line here is the amount, is 5 meters total water. So at that given time, we'll have 5 meters of water in that area. So what we're going to have a look is this priority bay here, and we've got a figure. I don't know if you can quite make that out, but what it is, it's a 2 with a line underneath it. So what that means, at the lowest possible tide, there's actually 2 meters of land there. And what I'm going to do, we're going to apply 3 meters of tide to that figure, and we're going to see how much actual water would be there at that given time. So what we've done is we've plotted our tidal curve for the area, and that's given us the answer for the given time of 3 meters of water, 3 meters of tide for that given point. And what I'm going to do, I'm going to draw it up on the board so it's a bit easier to understand. So what we've got here is we've got our chart datum line, which is our lowest possible tide, as I mentioned several times. And then what we've got here is the actual seabed. And notice how it's coming above chart datum, and it's actually a drying height of 2 meters. We've just seen at Priority Bay it's a drying height of 2 meters. Then what we've done is we've gone to our tidal curve, and for this given time it's given us the answer of 3 meters of water. So from the sea level to chart datum, there's actual 3 meters of tide there, which is here. So what that means is, to find out how much water's above this spot here, we've got to take away that figure from that figure. So 3 meters take away 2 meters, and that'll leave us with 1 meter of water at that point, at that given time. When you're looking at your chart, you may wonder how you find the height for a particular area. The best way to do it is look for your nearest standard port and work out the tidal curve for your standard port, and then that should give you a good estimate of the tide height in that area. If there's no standard ports nearby, you may well have to look at doing some secondary port calculations and using that as your tidal height.